the Panama Canal is an engineering marvel that we find unbelievable. Here are some things that might amaze you. Ships traveling between New York and San Francisco save 7,872 miles by using the Panama Canal instead of going around Cape Horn. The Atlantic entrance to the canal is 22.5 miles west of the Pacific entrance. More than 4.5 million cubic yards of concrete went into the construction of the locks and dams. Material originally excavated to build the canal were put onto a train of flat cars. It would encircle the world 4 times. The locks of the Panama Canal are 7 feet thick. Due to the reclining S shape of the Isthmus of Panama, while in Panama City, the sun rises from the Pacific Ocean.
Have you ever pondered the magnitude of engineering brilliance that went into carving a 50-mile-long waterway known as the Panama Canal? And do you ever wonder how this man-made marvel saves countless dollars in global commerce every day? In the late 19th century, the idea of the Panama Canal was born out of necessity. The arduous and expensive journey around the southern tip of South America was a significant hindrance to trade and transportation. The vision was clear: create a shortcut through the Isthmus of Panama to connect the Atlantic and Pacific Oceans. The planning stage was a monumental task in itself. Engineers had to meticulously account for the geographical and climatic challenges of the region. The canal would pass through mountains, swamps, and tropical rainforests, all while contending with heavy rainfall and potential diseases. Not to mention the political and financial hurdles that had to be navigated. Construction began in 1881 under the leadership of Ferdinand de Lesseps, the man responsible for the Suez Canal. However, the project was fraught with difficulties. The tropical climate posed serious health risks to workers, and the rough terrain made excavation nearly impossible with the technology of the time. After 8 years and the expenditure of 2 billion francs, the project was abandoned. In 1904, the United States took over the project with a new approach. They implemented disease control measures, improved infrastructure, and brought in modern machinery. It took a decade of relentless work, but finally, in 1914, the Panama Canal was opened for business. The operation of the Panama Canal is a testament to human ingenuity. The canal uses a system of locks to lift ships up to an artificial lake and then lower them back down to sea level on the other side. This ingenious method saves both time and energy, as it eliminates the need for pumps. The Panama Canal has proven to be an invaluable asset to global trade. By providing a shortcut between the Atlantic and Pacific Oceans, it significantly reduces travel time and fuel costs for ships. This, in turn, leads to lower prices for consumers and increased profits for businesses. In essence, the Panama Canal is a remarkable blend of engineering genius and economic foresight. Its planning was meticulous, its construction was Herculean, and its operation is a marvel of efficiency. It stands as a testament to human perseverance and ingenuity. The Panama Canal is more than just a waterway. It's a symbol of how engineering brilliance can overcome seemingly insurmountable challenges. And it's a reminder that when we invest in infrastructure, we're not just building for today, we're paving the way for a more connected and prosperous tomorrow. To summarize, the Panama Canal was born out of necessity, built with determination, and operates with an efficiency that saves billions in global trade. It's an engineering marvel that continues to inspire and facilitate progress more than 100 years after its construction.
The Panama Canal operates on a system of locks, a kind of water elevator for ships. It's not as simple as digging a ditch from one ocean to another. The land rises 85 feet at the continental divide and then falls back to sea level on the other side. To navigate the canal, a ship first enters the locks, massive chambers with steel gates. Water from the man-made Gatun Lake fills the first lock, raising the ship to the level of the next chamber. This process repeats until the ship reaches the lake level, 85 feet above sea level. The ship then sails through the canal, crossing Gatun Lake and traversing the Gaillard Cut, the narrowest point of the canal. On the other side of the continental divide, the process reverses. The ship enters the lock and water drains out, lowering the ship back to sea level. Once the water level matches that of the Pacific Ocean, the gates open and the ship sails out into the Pacific. To keep the canal functioning, maintenance is a continuous process. Workers dredge the canal to keep it deep enough for ships and maintain the mechanical systems of the locks. So, in summary, the Panama Canal works as a water bridge, lifting ships over the continental divide and then lowering them back down, using a system of locks filled and emptied by gravity. It's a testament to human ingenuity, a feat of engineering that revolutionized global trade and continues to facilitate the journey of ships across the world.